Hello, I'm KyuKim from International University, South Korea, studying microplastic fate and transport in polar region. Arctic is a unique environment covered with the sea ice. Microplastic can enter via ocean current, local source, and atmospheric transport and deposition. Previous studies showed several orders of magnitude higher MP numbers in sea ice and snow compared with seawater. However, different minimum crop size and types were measured among different studies, which could cause different results. So we can have several detailed questions with the main question of, is Arctic a significant thing of microplastic in our globe? Question 1. What is ice-trapped MP load and its fraction in global MP budget? Second, what is the contribution of atmospheric input to ice-trapped MPs? Third, how is the Arctic Basin linked in MP pollutions? Our team has collected a variety of polar samples over the past several years. You can see Antarctic study result in our Another e-poster. Today, I will show the result of sea ice, meltwater water, and snows, which were collected from 3 sea ice flows in Western Arctic Ocean. Today, I will compare MP data investigated in different Arctic basins. Number-based data is strongly dependent fragmentation and so not proper for MP budgeting. So I will show how number-based data differ from mass-based data. Sea ice repeat melting and freezing every year. So we calculated annual MP mass load trapped into WAO seasonal sea ice, as well as annual snowfall deposition flux on the same domain. From the estimation, we estimated the contribution of snowfall deposition to ice-trapped MPs. This slide shows the pictures of various MP types found in Arctic samples. Sea ice core showed the vertically very uniform MP distribution with depths. This slide compares MP data between non-fiber and fiber, between sea ice and snow, between the different basins. First, in numbers, non-fibers prevailed in small size ranges, but fibers in large size ranges. Second, for the same crop size and geometric shape, MP number-based concentration are much higher in sea ice than in snow from Eurasian Basin, also from Amerasian Basin. Sea ice and snow show the different polymer composition for both the two basins. For the same crop size over 100 micrometer and the same geometric shape, MP number per cubic meter was similar between Eurasian Basin and Amerasian Basin for both sea ice and snow. But Arctic Central Basin sea ice contained significantly lower MP pollution level than WAO sea ice, but the two basin sea ices had similar MP compositions. This slide shows how number-based MP data differ from mass-based MP data. In number-based data, both non-fiber and fiber show exponential increase with decreasing size. However, non-fiber much prevail in small size ranges compared with fibers. But in large sized ranges, fiber is more abundant than non-fibers. Mass-based data show completely opposite size distribution to number-based size distribution. mass concentration is much higher as size increased. Particularly, large-sized non-fiber accounted for most of total MP mass in a sample. Thus, detection of large-sized non-fiber is much important in mass budgeting. In a year, sea ice extent changes seasonally. For seasonal sea ice area, we calculated MP mass load. Sea ice trapped MP was 280 kilotons, which is comparable with those of global ocean floating MP amount. Annual snowfall deposition flux accounted for less than 1% of ice-trapped MPs. These are our conclusion. MP data significantly varies depending on MP cutoff size and geometry, and thus harmonizing different data sets by their cutoff size and geometry is important for their comparison. Large-sized non-fibers are rarely found in numbers, but their mass contribution is much great. Arctic basins are polluted at similar levels by MPs, with a much closer linkage between Arctic Central Basin and WAO, probably because of transpolar drift. WAO seasonal sea ice entraps significant MP amount, which are comparable to MP stock in global ocean surface. Unexpectedly, contribution of snowfall deposition was very small. We argue WAO accumulated significant MP amount missed from the global inventory, which might be caused by both trapping by sea ice and pivot gyre and one-directional Pacific water carrying input. Any questions? You can see the details in this paper, or you can leave the message to me via emails. Also, we are waiting for another paper regarding sea ice effect on MP sedimentation in the WAO. Thank you so much for your attention.